This is the key to part 2 of the section dealing with inverse functions. And number 1, you want to determine algebraically the inverse of this. So you have to show the work. It does say show work. So what you have to do is, and let's just go ahead and do that here. So remember, to do this algebraically, to find the inverse of this algebraically, you have to replace f of x with y. So I'm going to say y equal x divided by 4 plus 2. All right. Then remember, the next step is to interchange the coordinates. So x equal y divided by 4 plus 2, and then you solve for y. So the first thing you're going to do is to subtract 2 from both sides, just like this. So I get x minus 2 is equal to y divided by 4. And then to get y by itself, since I'm dividing by 4, I'm going to multiply by 4. But remember, you got to put that in parentheses. So the 4's divide out, and there's your inverse. So the inverse of this function is this right here. So it'll be 4 times x minus 2. Okay? Now don't distribute, just leave it like that. Because it kind of if you leave it like that, it kind of makes sense that the inverse of this is this. Okay? Now this one says, which of the following is the inverse of the function multiply by 8, then subtract 10? All right, so the opposite would be to, remember you're doing the inverse. So the opposite would be to add 10 and then do what? Divide by 5. So add 10, divide by 5. All right, number 3, which of the following is the inverse of this function? Well, it's the same thing as this. So let's just do this algebraically. Let's find out what it is. So you're going to replace f of x with y. So I get y equal negative 8 minus 5x. Interchange the variables. So I get x equal negative 8 minus 5y. And then we've got to solve for y. So I'm going to add 8 to both sides, and that's a negative 8, just like this. Okay. So x plus 8 equal negative 5y. And then I'm going to get y by itself. So you got to solve for y. So I'm going to divide both sides by negative 5, just like that. So I get y equal x plus 8 divided by negative 5. And so that's the inverse. So once you get y by itself, you found the inverse. So if this is f of x, then this is going to be f inverse of x. All right. And so let's see if this is listed anywhere. So, all right. So notice it's multiple choice. I don't see this listed anywhere, right? Okay. So let's think then. All right. I did not do anything wrong, but notice that these are listed as fractions. As two fractions. See? So let's go ahead and write this as two fractions. So this is to become x divided by negative 5, right? Minus 8 divided by 5. So a positive 8 divided by negative 5 is this. Okay, let's see if I see it now. So do I see it? Yep, right here, right? So isn't that this right here? So isn't x divided by negative 5 the same thing as negative x divided by 5? Okay, so it's going to be B. All right, so B. All right, now 3. G of x is this function. Is g of x a one-to-one function, right? Yes or no? All right, all you have to remember about this is this, that we got to remember what the definition of a one-to-one function is. So remember, the definition of one-to-one function says basically this. Now remember what a function is. A function says for each x coordinate, there's only one y coordinate. All right, so a one-to-one function says this. For each y coordinate, there is only one x coordinate. All right, that's what a one-to-one function is. So if you look at this right here, and I want you to think about that. All right, let's think about that. So here's my function that I'm looking at. So g of x is equal to 2 times x minus 3 squared plus 1. Okay. And I know from a previous lesson that this quadratic, so remember this is a quadratic function. And it is written in vertex form, right? Written in vertex form. Okay. So I know that a rough sketch of this, I'm just going to do a rough sketch of this. So I know that the vertex is going to be 3, 1. And I know that since A is positive, the parabola is going to open up. So I get something like this. So 3 1's in the first quadrant. And so I get something that looks like this, right? Okay. And so if you look at this, remember the definition of one-to-one means that for each y coordinate, there's only one x coordinate. So if we look at this y coordinate right here, let's say it's 4. How many x coordinates are associated with it? There are 2. So there are 2 x coordinates associated with 4. Same thing for all of these. And in fact, remember we talked about the horizontal line test? Horizontal line test. And so this parabola, this quadratic function right here, doesn't it fail the horizontal line test? All right, so the answer would be no, because it fails the horizontal line test. Let's just write it like that. It fails because it fails the horizontal line test. Okay, so it fails the horizontal line test. All right, mainly because, remember, the reason why it's failed the horizontal line test is because for each y coordinate right here, regardless if you use 4, 5, 6, whatever it may be, how many x coordinates are associated with it? 2. Definition says you can only have what? 1. Okay? All right, and then number 4. Okay, so let's talk about number 4. So number 4 says the graph of f of x is shown. So there's a graph of f of x, okay? And you want to graph the inverse. All right, and then I asked you also, I said make sure you graph y equal x, because remember that if that two functions that are inverse of each other, are symmetrical about the line y equal x right here. Okay, so you see how these are symmetrical about the line y equal x? Okay, so y equal x, first of all, let's just think about this way. So if x is 1, what's y? 1. If x is negative 2, what's y? Negative 2, right? So 1, 1, and then negative 2, negative 2, right? Like that. And then I'm going to use my ruler, and I am going to graph y equal x. Okay? So here's the line y equal x. Right here. So I'm going to go ahead and just use a dotted line here. All right, you didn't have to, you could have used a solid line, does not matter. Okay, now we want to graph the inverse. What I wanted you to do there is this. And remember in the previous lesson we talked about this. We said, all right, if two functions are inverse of each other, if the point 4, 2 is on this graph, then what's going to be on the inverse? 2, 4. All right, so what I want you to use here was that. Now remember, to graph a line you need 2 points. So see how I have 1 point here that's kind of shown? So if 1, 3 is on the graph, then what point's going to be on this one? 3, 1, right? Okay. And see right here we have 1 right here. If 0, 1 is on the graph of f of x, then what's going to be on the graph of the inverse? We said 0, 1, so it'll be 1, 0, right? Right here. Now you could have done this. You could have actually found the inverse. All right. Oh, and by the way, I'm just going to go ahead and graph it. So the graph's going to look like this. All right. So let me go ahead and make sure. All right. So let's go ahead and graph it. So it looks something like this. Okay. So there's the graph of f inverse. All right. Now that's all I wanted you to do. Now notice what I did though. I used the fact that I took 2 points from this line. All right, 2 points from this line. Remember, I could have done this right here. I could have gone here. Even if you didn't see it, you could have gone here, guys. Let's say x is 1. What's 2 times 1? Remember, this is f of x. Well, 2 times 1 is 2. 2 plus 1 is what? 3. So f inverse, what's going to be the coordinates? 3, 1. All right, so you see right here, 3, 1. If x is, let's say negative 2. All right. Well, I don't have enough room. Maybe I do. Yeah. So negative 2 times a negative 2 is negative 4. What's negative 4 plus 1? Negative 3. So if I plot the point negative 3, negative 2, oops, negative 3, negative 2, that's right here, right? All right. So I should have, see, it goes to there. All right. I didn't do a very good job with that, but that's where it goes. All right. So you could have done that. Okay, now you could have also, by the way, this would be negative 3, negative 2, right? So the point negative 2, negative 3 is on this function, then the inverse will be negative 3, negative 2. You could have also actually found the inverse. All right, so you could have found the inverse. So that's another way you could have done that. So f of x equal 2x plus 1. then y equal 2x plus 1, then you interchange the coordinates, all right, and then you solve for y, so you can subtract 1, so I get x minus 1 equal 2y, and then divide both sides by 2, and there's your inverse right here. So the inverse will be x minus 1 divided by 2. The problem with doing this, the problem with using this is that you have a fraction, so you got to be careful. So then you would have to pick some values for x. You would have to pick some values for x that would make these nice points to plot. Okay? So that's why the best way to do these when you have that kind of question is to pick 2 points on f of x, and then remember that if the point 1, 3 is on f of x, then 3, 1 is going to be in the inverse. If the point negative 2, negative 3 is on f of x, then the points negative 3, negative 2 will be on the inverse. This one's a little bit more difficult to do. So what you have to do here, if this is what you did, see, you have a fraction, so you have to be careful. What you have to do there is this. I'm going to go ahead and do this, rewrite this over, which is, I'm going to just call it y. All right, so we're going to use a t-table. Now what I would do is I would just find points for x that would make this a whole number. All right, so for example, if you use 2, 2 minus 1 divided by 2 is 1/2, right? Okay, now you could plot 2 1/2. You could do that. I mean, 2 1/2, that's about here. And that's no, 2 1/2 is not that bad to plot. See right here, there it is right here, right? If I let x be 0, I get 0 minus 1 divided by 2, which is negative 1 divided by 2, which is negative 1/2. So 0 negative 1/2 is right here, see? So you could have used some fractions here. And these are not that bad because 1/2. So you know that 1/2 is, you know how to estimate where 1/2 is. All right, so you could have done that. But the intent, though, was to, in this case, was to find points on f of x, and remember that if the point for 2 is on this function, then 2, 4 will be on its inverse. And so that's what I want you to use there. And I want you to graph y equal x, so that way you can make sure that it looks symmetrical. Okay? All right, so that's the key to this worksheet.